Welcome back again. In this section, we want to look a little bit more closely at what we mean by electromotive force as well as potential difference. Let's get started. And here are our learning outcomes for e.m.f as well as PD. Alright, so in the previous section, we talked about this circuit basically, and we want to see now what was the role of the battery. And in that previous lecture, I briefly mentioned that this battery was the source of electromotive force. Well, let's examine carefully what actually it does. What is electromotive force? Well, if you look at this analogy, one of my favorites, you consider it just like a big, well, kind of a circular kind of a tubing, like pipe filled with water. And if you just have the tubing filled with water, it's just going to kind of water is just going to kind of stay there stationary. If you want the water to move, you kind of need to give it a force, right? And you do that by putting a water pump inside there. And what a water pump does is that basically it creates a region of highest pressure, alright, and basically by pushing out the water, and that causes the water to flow from the area of highest pressure to the area of lowest pressure, where it enters back into the pump. Alright, and when this happens, water everywhere in that tubing will move, not just next to the water pump, and so in this case a water current is set up. So if you draw the same analogy, alright, to a battery, it kind of functions in the same way, right? And I mean, charges are kind of stationary. I mean, if you just have a piece of wire, even if you put it into like a circuit-like thing, but if you don't have a battery, the electrons in the circuit will kind of stay stationary. But if you were to put like a battery and connect it to the circuit, what will happen is that the electrons will start to move. And if that does, the electrons start to move, a current is formed. In a sense, the battery is doing work to drive the electrons around the circuit. And if you might remember, when a battery does work, the battery actually transfers energy to the electrons, and electrons actually have energy to do work elsewhere in the circuit. And here's the definition. As you can see, the electromotive force, the e.m.f, right, is basically the work done by the source in driving a unit charge around the complete circuit, right? And so straight away, as you might be a little confused in this case, but something that you have to be clear: the e.m.f, the electromotive force, has really nothing to do with force in terms of its measurement. It is actually something related more to the unit of energy. Alright, because there's something to do with work done. It is actually energy per unit charge. Alright, and that's why you see the equation for electromotive force is the work done W per unit charge Q. So in that case, if you were to see, what would the unit be? Well, if the unit of work is Joule and the unit of charge is Coulomb, therefore the unit of electromotive force must be Joule per Coulomb, or volt for short. So SI unit is volt. And how do we measure it? Basically, we find what we call a voltmeter. And voltmeters, right, are connected actually parallel to whatever you want to measure. Alright, so you just need to take note. You connect the positive side of the voltmeter towards the positive terminal of your electrical source, or for example your positive terminal of your battery, and you connect the negative side of the voltmeter to the negative side of the battery or electrical source. Okay, well, so that's one thing down. Let's look at the next thing: potential difference. What is potential difference? The potential difference across a component is the work done to drive the unit charge through the component. Well, as you can see, this definition parallels what was mentioned for e.m.f. Right? It looks very similar to the e.m.f. So in this case, instead of the italic or Greek letter epsilon e, okay, we have v. Okay, but the rest of the formula looks the same, exactly the same. Right, and Therefore, in that case, because just in the same way, work done per unit charge was joule per coulomb, and we use volts for that, we also use volts for potential difference for the same reason. But before we do that, I just want to highlight and just pause for a while. Just think about it. If you were to look at, for example, if you were to look at what we mentioned about the pump giving energy to the electrons, or just like imagine a pump giving energy to the water, and the water can flow in the pipe, it can flow through windmills, it can turn water mills, you can turn those water mills, you can run dams and things like that. So uh, energy essentially from the pump is transferred through through the water to these other things in the circuit. So in the same way, uh, energy is transferred from the battery through the circuit and to whatever is in the circuit. So it could be your light bulbs, it could be your resistors, it could be your heaters. So basically, the potential difference actually goes to give energy, transfer energy to these components, and when we transfer energy, we know that work is done basically. Alright, so that's the equivalence of work done as energy transferred. And how do you measure PD? Similarly, through a voltmeter, and this time we connect it parallel with the component. Do you notice that again the positive side of the voltmeter points towards the positive side of the electrical source? Alright, and we represent it like that. Here's a little nifty little table to state the difference between EMF as well as potential difference. Alright, so EMF usually talk about electrical energy source. Alright, it will be very much like the pump. It actually provides energy, right, to the electrons in the circuit. Whereas the potential difference is usually measured across 2 points in the electric circuit. Usually, well, why 2 points? Well, within these 2 points you could have a resistor. Within these 2 points you could have a light bulb. So within these 2 points, alright, we're interested in what is energy changing there. And whereas the EMF is done by the source to drive the unit charge around the complete circuit. Alright. In other words, it is only useful to talk about EMF in context of having a complete circuit where the unit charge can be driven around. Whereas in the PD we're done to drive the unit charge between 2 points. So we can measure between 2 points and not necessarily using the whole circuit. Alright, here's a question for you. What will this voltmeter reading show? Is it the EMF of the electrical source, EMF of the bulb, or the PD across the bulb? Remember what the definitions stand for and which one is associated with which. That's right. It should be C, the potential difference across each bulb. Alright, thank you, and we'll see you in the next lesson.